Hi, good morning everyone. My name is Harini and today's my topic is directional derivatives and angle between two surfaces. So now let us discuss what is the definition of vector differentiation. Vector differentiation is a comprehensive study of vectors, vector functions, derivatives, directional derivatives in three-dimensional space and angle between two surfaces. So let us discuss the difference between vectors and scalars. Vector has only magnitude and direction. Example, displacement, velocity. Scalar has only magnitude but no direction, whereas vector has both magnitude and direction. Now, example of scalar is distance, temperature, time, speed. So now, what is position vector and vector function? So the formula of position vector is any vector r bar written as r bar is equal to xi bar plus yj bar plus zk bar. Now let us discuss vector function expressed in terms of unit vectors I bar, j bar, k bar. F bar of t is equal to f1 of t I bar plus f2 of t j bar plus f3 of t k bar, where f1 of t, f2 of t, f3 of t are real valued scalar functions. This is vector function. So now let us discuss derivative of a vector function. So let f be a vector function and a belongs to R. The derivative at point A is f bar of A is equal to limit t tends to A, f bar of t minus f bar of A by t minus A, or we can write the formula as df bar by dt whole t is equal to A. Now, component wise, this is the product rule. Now, directional derivative. The directional derivative of a scalar point function phi at point p x comma y comma z in the direction of unit vector is given as E is equal to E bar into delta phi. Here, maximum directional derivative of phi is mod delta phi. This is the formula of directional derivative. Now here the question is directional derivative of f is equal to xy plus yz plus 2x. Find directional derivative in direction of I bar plus 2j bar plus 2k bar at point 1 comma 2 comma 0. Now let us discuss how to solve the problem. So now here they given f is equal to xy plus yz plus zx. So now we'll find gradient delta f is equal to I bar dou f by dou x plus j bar dou f by dou y plus k bar dou f by dou z. Now here the f is equal to xy plus yz plus 2x. Now if we substitute f in that formula I bar dou f by dou x plus j bar dou f by dou y plus k bar dou f by dou z, then we get final solution as in the PPT. Delta f is equal to y plus 2 into I bar plus x plus j in z into j bar plus y k bar. Now we need to find unit vector. So given vector is equal to I bar plus 2j bar plus 2k bar. Now E bar is equal to the formula of unit vector is equal to A bar by mod A bar. So now E bar is equal to I bar plus 2j bar plus 2k bar by mod I bar plus 2j bar plus 2k bar is equal to, after substituting we get that 1 by 3 into I bar plus 2j bar plus 2k bar. Now directional derivative, we'll find directional derivative. Directional derivative is equal to E bar into delta F. This is the formula. So now here they given delta F is equal to Y plus 2I bar plus X plus Z into J bar plus Y into K bar. So now here E bar is equal to 1 by 3 into I bar plus 2J bar plus 2K bar. If we substitute E bar into delta F bar, we get final solution 1 by 3 into Y plus Z plus 2 into X plus Z plus 2 into Y plus X. This is the final directional derivative. So if we substitute the point 1 comma 2 comma 0 as mentioned in the question, we get 10 by 3. This is the answer for the above problem. Now the position vector of P and Q with respect to origin is given by OP bar is equal to I bar plus 2J bar plus 3K bar. OQ bar is equal to 5I bar plus 4K bar. If we minus both, we get PQ bar is equal to 4I bar minus 2J bar plus K bar. E bar is equal to unit vector along PQ bar is equal to PQ bar minus by mod PQ bar. Here PQ bar is equal to 4I bar minus 2J bar plus K bar. So if we mention it in the above formula PQ bar by mod PQ bar, we get 1 by root 21 4I bar minus 2J J bar plus K bar. Now if we substitute this equation in the formula of delta F, we get delta F is equal to 2x into I minus 2yj plus 4z into k bar. So directional derivative at point P 1 comma 2 comma 3 is equal to E bar into delta F. Here at 1 comma 2 comma 3. So if we substitute delta F and into E bar, we get 1 by root 21 into 4 I bar minus 2 k bar j bar plus k bar into 2x I bar minus 2y j bar plus 4z k bar. So if we do the directional derivative at point 1 comma 2 comma 3, if we substitute those points 1 comma 2 comma 3, we get final answer as 28 by root 21. This is the directional derivative for the above question. Now let us discuss the formulas of normal vectors and surface formula. Now a normal vector to surface delta phi. Unit vector formula is E bar is equal to delta phi by mod delta phi. Now if we need to find angle between two surfaces, the formula is cos theta is equal to n1 bar into n2 bar by mod n1 bar into mod n2 bar. These are the formulas. Now, if we need to find angle between normal to phi is equal to x square minus yz with points 1 comma 1 comma 1 and 2 comma 4 comma 1. So we need to first compute delta phi. Delta phi is equal to, if we substitute the formula and solve it, we get delta phi is equal to 2x I bar minus zj bar minus yk bar. If we evaluate normals, then we get n1 bar is equal to 2I bar minus j bar minus k bar, n2 is equal to 4I bar minus j bar minus 4k bar. So as we mentioned the formula cos theta is equal to n1 into n2 by mod n1 bar mod n2 bar. So we get here, if we substitute the formulas, we get cos theta is equal to 13 by root 198. So, what are the key takeaways? So, vector have magnitude and direction. Scalar has only magnitude. Vector differentiation each compute f1, f2, f3 independently. Formula of directional derivative is equal to E is equal to E bar into del phi. Surface normal angle between surface is cos theta is equal to n1 bar into n2 bar by mod n1 bar into n2 bar. Thank you.